Okay, good afternoon students. Last class we studied about different regions of electromagnetic spectrum. What is spectrum? Okay, different region, properties, what is the effect, harmful effect, useful effect, all things are needed. Okay, let me check how much you have studied. All of you close your books. All of you close your books. Okay. Close your books. Okay. Okay. Trisha. Trisha.
Yes, sir.
Okay. Have you studied the topics which are taken last class?
Yes.
Okay. Close your book. Close your textbook.
I have closed.
Okay. What are the use of microwaves?
Microwave.
Use of microwave.
Uses
No use.
of
Yeah.
radar communication.
Then anything else?
The cooking purposes.
What?
Then radar communication.
Okay.
Satellite communication. Cooking purposes. And atomic structure to analyze atomic structure.
Okay. Fine. Kesmin. Ready? Okay, Kesmin. What are the sources of infrared radiation? Sources of close your book.
Closed.
Okay. What are the sources of infrared radiations? What are the sources of infrared radiations?
Fire.
Fire. Okay, fine.
Then flame.
Flame. Then all. What type of body?
Hot bodies.
Red.
Red hot bodies.
Red hot bodies. Yeah. Okay, fine. Helena. Helena.
Yes, sir.
Is there any harmful effect for ultraviolet radiation? UV?
Ultraviolet radiation. No, sir. Yes. Harmful effects are there.
Yeah, what is it? Close your book.
It can cause health illness in human beings.
Okay, fine. Okay, Alex, are you there? Alex? Alex, I can't able to hear you. Okay, Albin is not there. Andrick?
Yes, sir.
Okay, ready?
Yes.
Can you say this spectrum of electromagnetic radiation in the increasing order of frequency? All regions in the increasing order of frequency. Close your book.
Closed.
Okay, spectrum of electromagnetic radiation in the increasing order of frequencies.
Not remove, sir.
No idea.
I don't know, sir.
Spectrum of electromagnetic radiation in the increasing order of frequency. Hendrik?
Yes,
Okay.
sir, I don't know.
So 10 times today itself.
Oh, okay.
Okay, along with the notes, today you need to send 10 times its order also. Okay, we can see somebody else. Okay. Marin? Marin. Oh, two Marin. Marin Teresa? Marin Teresa? Marin? Marin Teresa, are you there? Marin Teresa. Okay, just talk, just talk. Marin Teresa, just talk. I think you are from mobile. Just talk, that's enough. I unmuted you, so just talk. Marin? Okay. Okay. Are you from okay. Marin, are you from mobile or laptop? Then your mobile mic is not working. You don't need to put any separate mics. You can use normal mobile phone. Just remove your headphone. Then you can use normal microphone in your mobile. Okay. Okay. Grace. Grace. Grace Joffy. Are you there? Wait. Grace Joffy. And
Yes, sir.
okay. And what are the use of ultraviolet radiation?
Uses of ultraviolet radiation. It can that germs. It can purify germs, and in food we can have vitamins.
Okay. Anything else? Okay, it's enough.
This much only I know.
Okay, anyway. So when I am muting few students, no response I am getting. Okay, make sure you are there. Else don't use. Okay, anyway, it's up to you. We can get back. So we can study about next section, scattering of light and its applications. Next section we are studying, section C, scattering of light and its application. We are going to study about scattering. Then after scattering, we will get back to our second chapter, a few topics are remaining. Okay, scattering of light and its applications. Okay, first of all, what is scattering? Okay. See, the scattering is a process of absorption and then re-emission of light energy. Similar scattering. Light energy is absorbed and re-emitted. Absorption and re-emission of light, that is called scattering. You know that sunlight has to reach us through atmosphere. Sunlight has to reach, they have to travel through the atmosphere for kilometers, almost more than 8 kilometers, they have to travel through atmosphere to reach us. So during this traveling, the particles in the atmosphere, so many minute particles are there. So many minute particles are there on our atmosphere. So these particles absorb the light rays and re-emit. So the sunlight have to undergo scattering, then only it can reach us. Okay, so that's a scattering, that's the meaning. So simply the definition wise, scattering is a process of absorption and then re-emission of light. Okay, so the dust particle and air molecule present in the atmosphere, all of them absorb that light and re-emit. That is scattering is occurring. Okay, just imagine I am standing here. If all the windows and doors are open, even though if there is no light source are there, I can get sunlight. You know that light can be travel only in straight line. Light can travel only straight line, but sunlight has to enter our rooms through windows. If light only can travel in straight line means only on roof only or in some areas only we will get the light. But we can get sunlight inside our house through windows, through doors. So everything is happening due to this scattering. The molecules or the particles around our windows absorbing light and emitting, re-emission should be in any direction. Okay, just imagine, okay, I'll show you the next example. Just imagine a water drop is falling on a stone. Just imagine on a slow motion video, a water drop is falling slowly and when it strikes, like that it will expanding. So same thing will happen here. The sunlight absorbed by the minute particle present in the atmosphere and they re-emit around us, around this direction, in different direction. See, the diffraction will not be, the direction of the re-emission will be any direction is possible. So this process is happening due to this scattering. If you take a fine hole in your windows or anywhere, if you take a fine hole, the light has to travel through the fine hole. How is possible the particles are scattering? Then, yeah, anywhere you can see that if you take a fine hole in your house, mainly at the morning it's only you can see that a small line will produce due to this scattering. A small line of light will produce due to scattering. So everything is happening, it's scattering. So everything is occurring due to this phenomenon of scattering. Okay, the scientist scattering is light is first studied by the scientist Rayleigh. Rayleigh is a scientist who studied about this process of scattering. Rayleigh, R-A-Y-L-E-I-G-H. Rayleigh is a scientist who studied about this process of scattering. Rayleigh said that the scattering depends on wavelength of the light. Scattering depends on, see, amount of scattering depends on, or scattering, intensity of scattering is proportional to the fourth power of wavelength. Scattering is proportional to the wavelength of light. Higher the wavelength, lower the scattering. Higher the wavelength, lower the scattering. So the scattering is explained by, how the scattering is occur is explained by the scientist called as Rayleigh. Okay, that's why sometimes we call this phenomena as Rayleigh scattering. Sometimes we call this phenomena as Rayleigh scattering. So Rayleigh is a scientist who studied about this process. This process of Rayleigh scientist who studied about this process of scattering. Scattering depends on wavelength. Higher the wavelength, lower the scattering. Higher the wavelength, lower the scattering. So as you know, if you take the visible light, which color have more wavelengths? Red. So red experience only less scattering. On visible light, red have more wavelength, so red experience only less scattering only. So the amount of scattering depends on wavelength. Okay. So in your textbook, there are so many examples are given related to this phenomenon of scattering. There are so many examples are given, so we can discuss. Okay, wait. Okay, so students, just wait. Yeah. So we can just go through some examples. There are so many examples are there textbook. See, just to study page number 145 properly. So most probably some application of scattering will not be there on your exam. Most probably I am saying. Okay, application of scattering. See, 145 introduction is there. Introduction is saying about the scattering. So introduction portion is there. But other than that, we are not expecting much detail. Okay. So we are expecting like that, not sure, but if any confirmation or anything is confirmed, I will explain you. So just understand what is scattering. Okay, that's more important. Just understand what is scattering. Okay. Okay, I will show a picture related to this. Okay, I will show a picture related to the scattering. Okay, phenomenon of scattering. First, I told you that. Okay, students, please wait. Okay. Okay, wait, students. Okay, so students, you can see a picture in your screen. Okay, see a window is there. See the light is entering to that room. Okay, see actually if light is traveling only in straight line means the light can't able to enter. Hope all of you see in your screen. Can you able to see the picture? Just respond someone.
Yes.
Okay. So yeah, okay, fine. See in this picture you can say that the light is entering the room. Okay, see here the light rays can enter. See, same thing you can observe. If the light is entering your house through any holes or something, same thing, a line-like structure we can able to see. That is happening due to scattering. Because if there is no air particle, there is no air around us, the scattering will not occur. There is no air around us, the scattering will not occur, the light will not enter the room. Complete darkness. Okay, so why light rays are entering into the room? Scattering. The air is around us, air is around the room. So normally what happens? The air particle absorb the light ray and re-emit. So that's why we are occurring. Maybe you are also familiar with the same situation. Your day-to-day life, you are also familiar with the situation. Air is reaching, means the light is reaching our house through a small holes or like that. Not, it's a larger one, but in small case you can observe this thing. So all these things are occurring due to the scattering. Okay, the scattering is inversely proportional to its wavelengths. Higher the wavelength, lesser the scattering. If you take that red color, have higher wavelength, red color have higher wavelength, so scattering is less. As you know that red color have lower wavelength only, so less scattering. But violet higher, red have higher wavelength, low scattering. Violet have low wavelength, so violet color will experience more scattering. Okay, so that how much scattering is how much the scattering is occurring, that also depends on the wavelength. So there are few situations regarding us related to scattering around us. Some application of scattering. Okay, anyway I am taking, I am not sure, I will confirm. First one, red color of sun. At the morning, means during sunrise and sunset, sun may be appears in red color. Okay, but at noon time, color of the sun is white or yellowish white only. Why it's happening? See, just imagine this is our earth, then around earth we have atmosphere. Just imagine somebody is observing from here. At the noon time, at the morning sun is here, noon time sun is here. The distance between us and sun doesn't change much. But at noon time, see, this much distance only sunlight is traveling through the atmosphere. But morning and evening sunlight, see the distance. And morning and evening sunlight have to travel more distance through the atmosphere. From the picture itself you can clear that. And morning and evening, same thing. Sunlight have to travel more distance through atmosphere. So what happens? It will experience more scattering. More distance means sunlight have to travel more distance. It means the sunlight will experience more scattering. The shorter wavelength colors means violet, indigo. So let's say shorter wavelength color, smaller wavelength, will lose due to scattering. And higher wavelength colors like red reach the observer. In our eyes, only red like colors will reach, higher wavelength colors will reach. So what we are seeing? We are seeing sun in red color. One more time, listen very carefully. At morning and evening or during sunrise and sunset. Okay, why sun is red color? That's what we are saying. Along with sunrise, during sunrise or sunset, sunlight have to travel more distance through atmosphere. That point is very important. Not about more distance. Through atmosphere, distance remains same. Morning and evening or at noon time no change. Distance remains same. But morning and evening sunlight have to travel more distance through atmosphere. It will experience more scattering. Shortened wavelength colors like violet, indigo and all lose due to scattering. They lose on the way. We will lose the colors. They are not reaching our eye. But higher wavelength colors, what's the advantage? Higher wavelength means less scattering only. So higher wavelength colors like red will reach our eye due to less scattering. So that's why we are seeing sun in red color. Same thing, white color of the sky at the noon, they are traveling less distance only. So low scattering, almost all colors are reaching our eye. At noon time, sunlight have to travel less distance through atmosphere only. So less scattering, sunlight will reach our eyes faster. So less scattering. So almost all colors will reach our eye. Next is white color of sky at noon. White color of sky at noon. So same thing only at noon time. What happens at noon? Sun is directly above our head. So sunlight have to travel less distance only through the atmosphere. It will experience low scattering. So almost all colors reaching our eyes without much scattering. So almost all the colors means we can see in white color. Then blue color of the sky. Why? Sky is in blue color. Same explanation using scattering. Why? Say it doesn't matter whether noon or evening, sky is always seeing in blue color. Why is happening? When sunlight reaches atmosphere, normally what happens? Scattering will occur. But shorter wavelength colors will experience more scattering. You already know that shorter wavelength colors will experience more scattering and spread around the atmosphere. Due to scattering, they are not traveling, they are just spread on the atmosphere, around the atmosphere. So, shorter wavelength colors experience more scattering and spread around atmosphere. So, sunlight have to travel long distance to atmosphere. So, before reaching us, it will experience scattering. Shorter wavelength colors will experience more scattering. Okay, so what happened? The colors like blue will spread around the atmosphere. So that spread color blue we are seeing as sky. Okay, see white rich the sky's direction. See the shorter wavelength colors will experience more scattering. So the spreading around the atmosphere. So we are seeing the sky in blue color. If you ask violet is the least one, yes, violet will experience more scattering. But the color we are seeing sky blue, it's not exact blue. First few colors, violet, indigo, blue, everything together almost mixed state we are seeing as sky blue. Okay, that's not exact blue we are seeing. So why sky is in red color? Before reaching our eye, sunlight have to undergo scattering. Shorter wavelength colors will experience more scattering. So colors like blue will experience more scattering and spread around the atmosphere. They are not reaching us, they are spreading on the atmosphere. So we are seeing sky is in blue color. Then what happens if there is no atmosphere? Not only here in moon or anywhere, if you observe the sky, there is no atmosphere means no scattering, nothing to spread. So we can see sky is in black color, not in white, black color. The black color of the sky in the absence of atmosphere. If there is no atmosphere, no scattering. So just all the light rays reach our eyes and we can see the sky in black color. Same thing if you observe the sky from moon, you can see the sky in black color. If you observe the sky from moon, you can see the sky in black color. Why? No scattering means, so no spreading, nothing is there. No atmosphere, no scattering. The same thing, clouds. Why clouds? You can see that not about black clouds, white clouds are there. Why there are white clouds? Reason is that, see, white cloud means the particle size is bigger than the wavelength. See, we already said that wavelength is high, scattering is less. Wavelength is high, scattering is less. There should be a particle which makes scattering possible. They absorb and re-emit. If particle size is bigger than the wavelength of visible light, if particle size is bigger than the wavelength of the visible light, all colors will experience same amount of scattering. If particles are too much larger, all colors will experience same amount of scattering. Okay, we already say that scattering depends on wavelength. It's normal condition. But if the particle is larger, all colors will experience same amount of scattering. So in white color, white clouds, particle is larger, same amount of scattering, all colors are reaching our eye. So what happened? White color. So all colors together we will obtain white color. So if particle molecular size is bigger than the wavelength of visible light, then they make all colors same amount of scattering. Then our eyes, all colors are reaching together. We can see the sky in clouds in white color. Next one is use of red light. If any danger signals, anywhere, traffic everywhere, stop signal, danger signal, everywhere use red. Okay, why red in traffic and danger signal? Same condition. Red have higher wavelength. Red color have higher wavelength. Higher wavelength means less scattering. So this red color can travel more distance through atmosphere without experiencing much scattering. If other colors are used, they can't reach much distance, far distance, because they will lose due to scattering. But red will experience only less scattering only. Red color experience less scattering only, so they can travel through atmosphere without much scattering. Few points only. Red color have shorter wavelength, so they can travel through atmosphere without experiencing much scattering. So they can travel far distance. We can able to visible that red signal far distance than any other color, especially this red color. That's why we using everywhere danger red. So this red color can travel more distance through atmosphere without experiencing much scattering. So everywhere in danger signal and all we are using red color. So these are the applications. Anyway, I am taken these topics. Okay, I will confirm. Okay, I will confirm these topics, all the topics again. Anyway, I have taken this topic. So if you have any doubt regarding scattering, you can ask now. Any doubts regarding scattering or any doubts regarding this chapter, you can ask now. Time for doubts. Which one? Okay. See, first of all, understand that. Wait. Yeah, I will explain. First of all, understand that these white clouds are more close to Earth's surface. Okay. First, these white clouds are more close to Earth's surface than they contain dust particle. If that particles are higher or bigger than the wavelength of the visible light, if particles are bigger than the wavelength of the visible light, the dust particle present in the clouds will scatter all color in same way. If the particles are larger, that's a property of the scattering. Already we say that depend on wavelength. That's why this difference is occurring. If particle size is larger, all colors will experience same amount of scattering. Okay, that's happening in the white cloud. Particles are larger, all colors will occurring same amount of scattering. So in our eyes, all colors are reaching together. Okay, in our eyes, all colors are reaching together. So we are seeing them in white color. Okay, clear? See, wavelength and scattering inversely proportional. Intensity of scattering inversely proportional to the I proportional to 1 by lambda raised to 4. Okay, I proportional to lambda raised to 4. See, red color of sunlight and sunlight. So I told you, at morning and evening, sunlight have to travel more distance through atmosphere. Why? We can't able to see the sun in all time as red or in any other color. Morning and evening, sunlight have to travel more distance through atmosphere. Okay, so they will experience more scattering. Shorter wavelength colors like loose due to scattering. Shorter wavelength colors like violet, indigo, blue will lose due to scattering. Only higher wavelength colors will reach the observer. Okay, in this section, see in this section only simple numerical only. Okay, mainly regarding this, okay, nothing is given in the exercise. Simple numericals only regarding frequency, wavelength, that calculations only. Don't expect much difficult numericals. Okay, no numericals are given in exercise, I think. Yeah, no numericals are given. Okay, any doubt, students? Anyway, just study this topic. Okay, I will confirm whether it's removed or not. Okay, because still I am waiting. I will confirm again. Okay, later I will confirm what are the list. Final list I will confirm. On the final list I will confirm. So, yeah. Any doubts, students? See, from the diagram is clear. One four zeros.
6 point.
What?
This red color sunrise.
Anyway, see the board. That's the diagram enough. You can see the board diagram. The diagram enough. Okay. Morning and evening, more distance, so more scattering. Noon time, less distance, less scattering. Agna, that kind of numericals already given the tests. I think it's solved one. Yeah, okay, I'll show you. Again, that kind of numericals are given page number 137. Page number 137, right side, you can see that solved one. You can see that. That definite numerical, that kind of numerical. 137, right side, means just above section exercise 6A. You can see that solved numerical. That substitution only. Page number, can you see that? Page number 137, right side at the top. Again? Okay. So, any more doubt, students? Okay, so we almost completed this section. This chapter is over. I know numericals are remains. Just to complete everything else other than numericals. Okay, that's a better I'm saying. Numericals are needed. I know it. Okay, wait. Wait. We need the numericals, but need time. Okay, wait. Okay, see, next class we can deal that missing portions. Okay, I know one class is taken, in other class is not taken. So anyway, be on time, be online. Both class be on time, be online. Okay, both class be on time, because in one class one topic is taken, other class one topic is not taken. Like that is going on. So we are taking both topics next class. I mean that. Wait, that conservation of energy. Next class we take the conservation of energy. Then on the machines we are taking that. Machines we are taking about that pulley. That final velocity ratio using several pulleys in block diagram. Then the calculations and all that we are going to take the topics. Okay, wait. That topics we are going to take. So that we can take next class. Then thereafter we need something from that. See, there's one section for that numerical section is there on the light portion. Sign conversion and lens formula. Okay, that also we need to take. I need to give some equations and sign conversion. That's all. Okay, so that's also we need to solve that from sign conversion and magnification, few equation that needed. Okay, that page number 122. Okay, the derivation is not needed, but other than that, things are needed. So that also we need to take on next class. So both one section is already taken for one class, but everything else is new for you. So beyond time, we can take that thing for just a sample. I'll show you one numerical from this chapter. Okay, just a sample numerical only. You have to solve these questions. How to solve this kind of question. Okay. After that only we will go to this magnetism section. Okay. After that we will get the electricity and magnetism. After this only 3 more chapters are remaining. Okay. After these 3 chapters, full time we have to spend for numerical. Okay. I'll show you one numerical. Okay. Just a sample numerical only. Anyway. Okay, students, just to take page number. Wait. Yeah, page number 136. Page number 136. Okay, sorry, 138. 138. First question. Okay, all questions are same type only. And first question I am saying. Just solve this question. Question is calculate the frequency of yellow light. Wavelength is given 550 nanometer, speed of light is given. So we need to find frequency. Simplification. F equal to, sorry, C by lambda. Here light, normally we use V by lambda. If light is using, we use C by lambda. Okay, we know the value of C. You can use the C value everywhere. 3 into 10 raised to 8 meter per second. Everywhere you can use. Then see 550 nanometer. So you need to convert into meter. Nano to meter means 10 raised to 9. Okay, 10 raised to 9 nano. Okay, nano to meter means 10 raised to minus 9. Okay, 10 raised to minus 9 will give nano to meter. Angstrom means 10 raised to minus 10. Nano 10 raised to minus 9. Micro minus 6, milli minus 3, centi minus 2. Okay, centi means centimeter or anyway, centi 10 raised to minus 2, millimeter or whatever may be 10 raised to minus 3, micro minus 6, nano minus 9. Then Armstrong minus 10. Then P is a picometer or whatever may be, 10 raised to minus 12, like the unit gun, centimeter, millimeter, micrometer, anyway, centimeter, millimeter, micrometer, nanometer, Armstrong. You normally don't use the other term, picometer, anywhere you can convert like this. So here it is. Nano range, nano is given 10 raised to minus 9. So if we can take this term up, okay, then we will obtain as 3 by 550 into 10 raised to 8, again into 10 raised to minus time like 10 raised to 9. They will move up, it's become positive. Okay, then just to divide this one, 3 by 550 into 10 raised to it's become 17. Okay, so next thing is you need to divide these two number. Okay, then you will obtain a 0 point something value. Okay, I know. Okay, just take time, just divide these two number, 5 by 550. Okay, then adjust with the power. Okay, you will get 0.00 something. Okay, that's all. Just divide. That's all. That much hertz. Just divide 5 by 550. Okay, then you will get that much hertz. Okay, when you are dividing, 3 is inside, 550 is outside. Okay, taking this way. First, not going 0 point, again 0, 0. Okay. Again 0, 0, then divide. Case dividing only. You can cut 1 zeros, then 5, okay, like that. Okay, then you will get 5 point, yeah, 5 point something value you obtain. Again, it's this kind of numerical you asked. Agna? Okay, just chat. I can able to hear you. Just chat. Yeah, okay. Any more doubts? What's your doubt? Which power you have doubt? It's about the power of that conversion. Wavelength meter, Megalem. Wavelength meter. For wavelength, use meter. Okay. That convert into whatever may be the unit given, convert into meter. Okay. Can you able to see this till end? Can you able to see, students? Okay. So all the conversions are given. Okay. See, okay. Okay. Conversion to meter, okay, not for centimeter. Conversion to meter. SI unit is a meter. So how to convert all into meter? That's saying. Okay. So any more doubts? Anybody? So same method only, easy method only. In this chapter, numericals are so easy. You can do by yourself. Just simple calculations only. Any more doubts? Anybody regarding any topics in this? Just to go through this whole unit. Okay, this yeah. Just to go through this whole unit. See, only thing I skipped is section C only. I think that numericals, I heard that it's not needed, but it's needed only that numerical from power of lens is removed. Everything else is needed. So anyway, we have to take the topic sine conversion and lens formula. We take magnification. Okay, anyway, I am not taking. Just I will give the idea. Okay, after that I will give just an idea, but I can't ask for exam. That's all. About this magnification, I will give you. Anyway, after this topics, after completing portions, I will give just an idea. What's the topic saying about it? Okay. Anyway, what are the topics skipped? We are not skipping by theory wise. We will take that topic, but it's not for your exam. Okay. So, any students, any doubt? Anybody? Just respond.
Examine the external properties.
What?
And the external properties of radiation are just
All. Yeah, steady. Because they don't ask anything. No, Trisha, wait. See, Agna, what is the issue? I don't understand what you are saying. So, dividing means the instead of a larger or smallest number, take the numerator inside it and take the denominator out. Okay, see, for first is it was just 0, 3 only. So 0 times 550, we can take. So that's why we are adding the denominator 0. Then we have to put 0 and numerator also. Again, I don't understand what you are saying. So about dividing. Agna? Yeah, that will adjust with the power. Agna, 10 raised to 7 is there. 10 raised to 17 is there. You will obtain 0.00 value. 10 raised to 17 we are obtaining. You test to be 10 raised to 14 or something. So that means zeros we are correcting. Your textbook answer is 10 raised to 14, I think. I don't check the answers. Here is, see, here is 10 raised to 17 is there. So that power is adjusting here. 10 raised to 14, we can adjust here. We will get correct answers only. Again? Yeah, 5.4 into 10 raised to 14 is the answer in textbook. Here it's 17. So 3 numbers, just adjust. Textbook is 5.4 into 10 raised to 14. Here our power is 10 raised to 17. So 14 to 17 numbers are there. So that number, 4 number I think, that number you need to correct there. Just understand, okay, see, if you take an example, if I take an example means, yeah, any power is fine, but should get properly. See, here our answer is 5 by 550 into 10 raised to 17 is there. Okay, so it means, see that it means you need to remove three zeros. Yeah. Yeah, that's fine. Albin is correct. Albin, you are correct. Albin, you are correct. No problem, no problem. Renew also correct. Yeah. Yeah, Albin, Renew, you are saying is correct. You can write either in both way. It's better, just try to put, okay, see, always I am saying, it's better way, put decimal point after the first digit. That's the better way of answering. Put decimal point after the first digit. Okay, so try to adjust in that way. That's a better. So that's a perfect way of answering. Rearrange as put decimal point after the first digit. Okay, see, when you are checking your answer sheets, we get the key. Okay, teachers will get the key for the answers for each. On the basis of that, all the answer sheets will check on board exam. So on key, they will give the answer as put with the decimal point after first digit. They will put the answer. Okay, normally, yeah, that's a better way to write. Okay, whenever answering in a numerical, it's better to write. Put your decimal point after the first digit. Okay, Agna, just talk, then I can clear you properly. Agna? Agna? Yeah, Agna, what is your doubt? Just speak, just speak.
In text, we are getting 5.4 to 10 raised to 14 now.
Okay.
But when you do in the board, we are getting 0, 0, 0.
Yeah. Into 10 raised to 17 we are getting. So we need to adjust that number here. Then 5 it's become 5.4. See, both are same number, Agna. Just to go through both number. Just divide these two number. We are getting both numbers, same number we are obtaining. We have 10 to see the power, 10 raised to 17 is here. It means if you convert into 10 raised to, if you convert into 10 raised to 14 means we need to adjust this much number, 4 means. So all other number we need to adjust this side. Then it will obtain 5 points. Just divide, you just divide. Okay, don't worry about what you have done. Just divide these two number. Okay, just divide these two number. First, yeah, 5 5 0. Yeah, it's out and 3. First you put it's not getting, you can't divide, so put 0, 0 here, again 0, now point, again 0, now you can divide. Okay, just divide. Okay, first 0 point, second 0, okay, wait. Okay, see 3 is here. For first point, you put 0. Second 0, you can divide, again 0. Third time 0, you need to put 0. Now you can divide. Okay, 2 zeros only. After the digit 2 zeros only. Now you can divide 5 times. Okay. Yeah, Trisha, you correct. Trisha, you correct, but it's better to use 5.4 word. Trisha, you are correct, but put the decimal point after first digit. Okay, Agna, actually I didn't understand what your doubt is. Is there any more doubts? Trisha, your written is correct. Okay, but better way is 5.4. Write in that way. Agna? Agna?
Yes.
Yeah, what says she now?
No, I understood.
Okay. So, yeah. Anyway, so yeah, you can go offline. See you next class. Okay. Agna, just divide. Just try to divide. You will get the proper answer.
Yes, sir. I
Yeah.
understood.
Okay. So you can go offline. See you next class. Okay. Thank you.